All right, here we have the second part of 6.4. Many applications in physics and engineering are required that a vector be decomposed into the sum of two vector components. So what we're going to do is, in this box, we're going to go through what that kind of explanation is. We're going to let the vector u and the vector b be non-zero vectors, such that u is equal to w1, here's w1, here's w2. w1 plus w2 is going to equal u. w1 and w2 are orthogonal, and w1 is parallel, or multiple scalar, of v. Vectors w1 and w2 are called vector components. Of u. The vector w1 is the projection of u onto v, and it's denoted by w1 is the projection, v is a subscript, u. So the projection of u onto v. This is terminology you're going to have to get familiar with. So when you read something is the projection onto something else, you need to know how it's set up. So the projection of u onto v. w2, so w2 is going to be the vector u minus w1. So once you know the projection of u onto v, then it's fairly simple to find w2. Okay, let's go on to page 5. Let u and v be non-zero vectors. The projection of u onto v is w1. Okay, so what is projection of u onto v? Is the dot product divided by v's magnitude squared times v. So on example number 6, when it says find the project of u onto v, should be projection of u onto v, then write u as the sum of two orthogonal vectors, one of which is projection of u on v. All right, so let's break this down here. We have the projection of u on v is this formula. So it's the dot product of the two vectors divided by the magnitude of v. So that is the square root of 6 squared, 2 squared, squared, times the vector v. All right, so when I do some calculations here, I'm going to get 18 minus the 10, 18 minus 10, we get 8, 36, 4 is 40, square root squared, so 40 times the vector. So that really gives me 6/5 and 2/5. Then it says we're going to find the component of U orthogonal to V in the homework tonight. You're going to need that terminology. I think it's number 39 and 41. So now, let's see. We're going to find W2 is U minus W1. And we know W1 because W1 is the projection of it. So we get 3 negative 5, subtract 6/5, 2/5, which is the same as 9/5 and negative 27/5. So U then is W1 plus W2, which is 6/5, 2/5, and this is just a proof. 6/5, 2/5, 9/5, negative 27/5, and if you put that together, you get 3 negative 5, which is exactly what we started with. So we write U as the sum of two orthogonal vectors, one of which is the projection of U. So here's U as the sum of two vectors, W1 plus W2, because one of them is the projection of U. Example number 7 is actually number 55 in our homework. A 600-pound boat sits on a ramp inclined at 30 degrees. What force is required to keep the boat, I should say boat, from rolling down the ramp? All right, so first of all, because the force of gravity is vertical and down, the force is negative 600 J, which is 0, negative 600 if we want to put it in vector format. Just starting from the beginning, force downward is 600. To find the force required to keep the boat from rolling down the ramp, we're going to project F force onto a unit vector, V, in the direction of the ramp. Okay, so we're going to project V onto F. We know this angle is 30 degrees. It was given to us. So the vector between, the angle between here, I'm sorry, with the horizontal, the vector is cosine 30i and sine 30j, of which we know these values. Cosine of 30, root 3 over 2i plus 1/2 j. So W1, which is the projection of F onto V, is the force vector times the v vector. Divided by the vector squared times v. Okay, because this is the unit vector, and that's what we said it was going to be, the unit vector, it equals 1. So in this instance, we don't care about the denominator. It goes away. We know the force is negative 600. We know the vector of v, because the is the 1/2 of v. Which equals negative 300 times the vector, root 3/2 I plus 1/2 j. But the reality is this vector is not important to this force. So the magnitude is 300. So 300 pounds is what is needed in order to keep the boat on the ramp. And I'm sure we'll be talking more about this example in class. All right, page 6. The work W is done by a constant force, F, acting along the line of motion of an object. W, or work, is the magnitude of force times distance. So what this translates to is the magnitude of force and then the distance of the vector. This is the force of line on motion, the line of motion. So if the constant force is not on a line, then work is done by a different formula. Work is the magnitude or distance of the projection of the vector, of the force on the vector times the magnitude of the vector. All right, what that equals then, because we know what the projection of force is, that's the cosine of theta times force in the magnitude of the vector, which simplifies even down further to the force times the vector. Now keep in mind, this works if it's not along a line of motion. All right, the definitions of work is what we just talked about. So the projection form, copy this. All right, the dot product form, copy that. Projection form, dot product form, same parts of the same puzzle. All right, so if we're going to find work, and I believe these attach to number 59 and 61 in the homework here, when you're using projection form, It says to close a barn door sliding, a person pulls a rope from a constant force of 50 pounds at a constant angle of 60 degrees as shown in the figure. Find the work done in moving the door 12 feet to its closed position. We want to use this projection form in theta because it gives us the angle. Because it gives us the angle, the cosine is a much better option here. This cosine one is a much better option. So work is the cosine of the angle times the force of 50 times the distance of 12. So the cosine of the angle multiplied by the force and the vector, which is the distance, length. So multiply those, stick it all into the calculator, or we know 1/2 of cosine is 60, but you could use your calculator as well, and you get 300 foot-pound is your force. So like I said, you're going to use that in your homework problems number 59 and 61 on the assignment of that. So that takes care of the second part of 6.4.